All right, so here's an example of how to do an Atwood machine problem. Okay, in a simple Atwood machine, two unequal masses M1 and M2 are connected by a string going over a clamped, light, smooth pulley. This is important. Okay, and that means no friction and no mass, which you'll see why that's important later. In a typical arrangement, mass 1 is 300 grams, okay, which is 0.3 kilograms, and mass 2, 0.6 kilograms, okay? The system is released from rest. All right, find the distance traveled by the first block in the first 2 seconds, okay, and find the tension in the string and find the force exerted by the clamp on the pulley, okay? So again, just like force problems, all of these are exactly the same, right? You're going to just do the same exact thing every single time, okay? All right, so you have two choices how to solve it. You can either look at the system or individually, okay? So let's draw both because I'm not sure what we're going to want, okay? So this is going to go this direction, right? Because that's the heavier one. So you're going to look at that as the positive direction, okay? So even though it's up on the left and down on the right, we're going to consider that whole thing the positive direction, okay? So if I look at the whole system, right? Okay, I have pulling in the positive direction, okay? That's the FG of mass 2. Okay, and then pulling in the negative direction is FG of mass 1, okay? Even though, notice it's up and down, right? Like it doesn't make any sense for the FG to be down, but we're thinking of it like, how can I draw this? Like this whole entire thing is just one object, okay? So the FG2 is pulling it in a positive direction, and the FG1 is a negative direction. Okay, you could draw it horizontally, I guess, if you want, okay? So if I sum the forces, okay, equal to MA, we're talking about the system, okay? So I'm going to say this way on my picture is positive because that matches what I put on the top. So my FG2 minus FG1 equals M total A, right? Because it's the total mass of the system because that whole system has to accelerate, okay? So this is going to be M2G minus M1G equals M1 plus M2A. All right, and then I'll just divide by M1 plus M2. Okay, then I get this expression. I can factor out the G, I guess. M2 minus M1 over M1 plus M2. Okay, so that might be a common thing without any numbers. You might need to get to that point, okay? All right, so you always need to find the acceleration of the system. Even, who cares what it's asking, you're going to need the acceleration of the system, okay? All right, so let's try to plug this in then. I guess I'll use 9.8. Okay, and then M2 is 0.6 minus 0.3. Okay, divided by their total. And where's my good calculator? There it is. Okay, so 0.3 times 9.8 divided by 0.9. Okay, so the acceleration of the system is 3.27 meters per second squared. Okay. All right. So once I know the acceleration of the system, then I can go ahead and find whatever else it asked me for. Okay, which I can't remember what it was. The V naught is 0. It wants to know the distance traveled by the first block. And again, who cares if it's the first block, right? Because they're all connected in the first 2 seconds. Okay. And I know my acceleration is 3.27. All right. So I'll probably go ahead and use this guy. Okay, that goes away. How convenient. Okay, 1/2 a t squared. And I'm breaking my own rules by not putting the units in, but it's late and I'm tired. 0.5 times 3.27 times 4, 6.54 meters. Okay, right, and since it says distance, we don't really care about the direction, right? So the block 2 would go 6 meters down, and block 1 would go 6 meters up. That seems awfully high, but I guess that's right. Okay, all right. Okay, so almost always there's going to be a question with the acceleration and some kind of kinematics-y thing. Okay, all right, part B, the other thing they're almost always going to ask you is the tension in the string. Okay, So to find the tension in the string, you need to just look at one of the objects, okay? So this one is going to have a lower tension of the string. Actually, I should probably draw it further over here. I'll draw one over here and then two over here. Okay, so this one is going to have the FG2 is bigger than the FT, right? Because it's accelerating downwards, okay? And then here, the FT is bigger and the FG is smaller, okay? It should be half, right? Because it was half as much mass. These are the same force, okay? These are the same force, right? Because they're all in the same rope, okay? So you can really do either of them if you want. So I'm going to use this one because that's a positive direction, okay? This way, that's a positive direction. Actually, it doesn't even matter. I'm going to actually use the block one, okay? So sum of the forces equals MA for block one, okay? So FT minus FG1 equals M1A, okay, because up is positive on that side. That's why I put the FT first, all right? And then the FT is going to be FG1 plus M1A, okay? And then watch what happens. Do you see this is going to happen a lot too? Okay, I don't have to do this, but that's just like a nice little thingy, okay? Factor that out. Okay, so the FT is going to be, M1, which is 0.03, 9.8 plus 3.27. 9.8 plus 3.27, okay, times 0.3. Okay, so the tension is 3.92 newtons. Okay, which makes sense, right? Because if the mass is 0.3, then the FG here is going to be 3. Okay, so I know the FT has to be bigger, so that's good. Okay, and smaller on the other side. Okay, all right, and then the last thing that I didn't know how to do last year, but now I know. Okay, if you have this pulley, right, they're asking you now, what is the force that's holding the pulley to the ceiling? Okay, the force exerted by the clamp on the pulley. Okay, so on the pulley, right, the pulley's being pulled down with the force of tension on either side, right? Because like if I kind of followed this force diagram around, right, it's going to be that, okay? So there's tension in that rope, and remember, the tension in the rope is the same everywhere, and then there's going to be some supporting force, let's call it a normal, I guess, from the pulley, okay? Right, and the pulley is not moving, so then I'll do the sum of the forces equals MA, but that's 0, right, because it's not moving. So up, I have Fn minus Ft equals 0. Okay, so that pulley force has to be twice of the tension force. Okay, so 2 times 3.92, which is whatever it is, 7.84. Okay, right, because the pulley itself is going to be at rest. All right, and that hopefully is that. Leave it on there for a second in case you want to pause it.